All right, so what we're going to do together here, you guys, is we are going to review for a 1 and 2 variable inequality assessment. This is meant to be paired with that, but if you're watching this just to get a review, that is fine as well. But for some of my students that I'm preparing this video for, well, this is going to look just like the assessment that you're going to do. So let's walk through it, and then you can use it on the assessment kind of as a resource and hopefully feel like you're confident with that. And so record these answers, pause the video if needed. And so 1 through 3 are just going to be some multiple choice. Last number of class periods, we've been working through problems with inequalities in 1 and 2 variables. So this one talks about which inequality represents the statement. You must be no more than 48 inches tall to ride the roller coaster. No more. So if you cannot be any more, then your height has to be less than 48 for sure, because you can't be more than. But could you be equal to 48? It just says you can't be more than. So yeah, your height could be equal to 48 or less than 48. So less than or equal to is going to be our answer here. And so x is less than or equal to 48 would go with G. So just be thinking about whatever the statement is here, where I think we've used the term at least and more than and less than and all of those, but no more than means less than or equal to. Our second problem here is related to a 2-variable inequality. You notice it's graphed over at the right, so let's take a look at this graph. If we're thinking about our y-intercept and our slope, that should help us. So here's the y-axis here. The graph is crossing the y-axis at -2, so the y-intercept is at -2. And then let's find another pretty point on our graph here to see if we can figure out the slope. So a pretty point looks to be maybe right there, maybe right there again. So if we think about a rise over run between these 2 points, notice the line is sloping upwards, positive slope, and we're going up 1, 2, 3, 4, and then to the right 1. So as a slope, as a rise over run, rise +4 and run +1. So 4 over 1, or just 4, would be our slope value. All right, so let's look at the problems over here, y equals mx plus b, that's in an inequality format where you have a +4 slope and a y-intercept of -2. Oops, I noticed that we have a little error here with our options, so actually none of these would apply, right? I'll have to fix that. Let's change these all to 2's. All right, that hopefully makes sense then, because it's clearly a -2, right? Not -1. So, all right, I'll have to make note of that little typo. All right, so +4 for our slope and -2. So it could be either this one or this one, but definitely not that one and not that one right there, because those have 1/4 slopes, not 4 for slopes. All right, so then let's look at our line. Notice it's a dashed line. So dash means it's not equal to. So dashed line, it's not equal to, which makes sense. None of our options have an equal to part of it. It's always less than or greater than. And shaded above this line, kind of above and to the left, but the shading is above. That means all of the possible points, x, y values that work, that if we plugged into our x and y values in the inequality would make true statements, and they're above the line. So above, it's shaded above, you should be thinking, okay, well, that must be a greater than symbol. So therefore, our answer is going to be y is greater than 4x minus 2, and that would be G. All right, so looking back at the previous problem now, think about those solutions that we talked about. Which one of these would be a possible solution? Let's take one by one. 2, 0. 2, 0 is right here. Is that in the shaded area? No. If we put 2 and 0 in for x and y, we would have a false statement. 4 times 2 would be 8. 8 minus 2 is 6. And so that would mean 0 is not greater than 6. So that's a false statement. -4, 1 is our next one. -4, +1. Okay. So that one is in the shaded area, so look no farther. We have found a solution that works, but just checking 4, 2 doesn't work. 1, 2 is on the line, but it's a dashed line, which means that the solutions cannot be on the line. So -4, 1 is the one that works. For our next one, we're saying for the inequality x is greater than 6, greater than, list 3 possible solutions. So what's that saying is tell me any numbers that are greater than 6. List 3 of them. So tell me a number that's greater than 6. Well, 7 is greater than 6. So x equals 7 would work. 7 is my favorite number. 10 is greater than 6. 1 million is greater than 6. Okay, there's 3 numbers. All right, but 5 is not greater than 6. 0 is not greater than 6. So we're looking for 3 possibilities. There's an infinite amount of solutions here. Anything greater than 6 would be a solution. Graph, x is less than 13. On the number line. All right, so we're basically just taking what we kind of had in 4, it's a slightly different one, but showing it on a number line rather than just stating the solutions, because since there's an infinite amount of solutions, I can't list them all, but I can kind of use a number line to help me. 13 is where our solutions are starting, but notice it's not equal to 13, so we represent that with an open circle. If it was also equal to 13, we would fill in our circle. And then all of the solutions for x are less than 13, which means our arrow has to go to the left. All the numbers less than 13 would work. 12 would work, 11 would work, 10 would work, 9 would work, and so on. All right, the next one is similar to number 5, except for we have to solve it first. In other words, we have to get x by itself. So think about solving. This is just a one step here. Subtracting 9, the opposite of subtracting is to add. So bring down what's left, x, and then 1 plus 9 would be 10. So x has to be greater than 10. So just like the last problem, let's think about, all right, 10 on the number line is right here. It's not equal to 10 though. So once again, open circle. But this time x is greater than 10. So that means all the numbers into infinity to the right of that on the number line, into positive infinity from 10, would be solutions. So that's how we can represent solutions in one variable. Notice these are one variable just with an x. Let's flip to the backside then. So we have another situation in which we have to solve the inequality. Notice I don't have a number line to graph at this time, but we do have to solve it and indicate what are the possible solutions. When we solve, remember, we use our reverse order of operations, SADNet sort of steps, or we think about undoing from the outside in. Think about -5 times w plus 16 is less than 36. So look at the same side of the inequality. We usually start off with adding or subtracting. In this case, we have an addition of 16, so the opposite to undo it would be to subtract 16. Bring down what's left. -5w is less than 36 minus 16 is 20. -5 times w, when we have a coefficient in front of a variable, they are being multiplied, and the opposite of multiplying is to divide. Divide by that number. So divide both sides by -5, cancels out to positive 1w, which then would be, whoops. Notice that we actually divided by a negative this time, and I almost forgot myself. And when you divide by a negative, or if you multiply by a negative, that flips the inequality symbol. So it flips right here. You might want to make a note of that just so you don't forget that on the actual assessment. So flip the inequality symbol here to a w is greater than instead of less than, and 20 divided by -5 would be -4. Don't have to graph this one, but the solution would be w is greater than -4. Number 8, similar question, but this time we are going to have to do maybe a step or two more. And so notice we have our variables on both sides of